So far, we've seen many different types of functions. In Chapter 2, we studied linear equations whose graphs were lines. In the last section, we studied quadratic functions whose graphs were parabolas. And previously, we also saw cubic functions whose graphs look like the following. For each of these types of graphs, if they contain the point 0, 0, then we call these types of functions power functions. We can also define a power function as follows. Y is equal to kx to the n, where we have that k and n are real numbers. N is a positive integer, and we also call k the coefficient. We will now practice identifying power functions. Let's go ahead and identify the following functions as a power function, quadratic function, both or neither. In part A, we're given f of x is equal to x to the fifth. By definition, this is a power function. The coefficient k of this power function is equal to 1, and n is equal to 5. Moving on to part B, we're given f of x is equal to x squared raised to the third. First, let's simplify this. This is equal to x raised to the sixth. Then again, by definition, this is a power function. The coefficient is equal to 1, and we also have that n is equal to 6. In part C, we're given 2x squared minus 1 divided by 3x plus 9. Up top, we have a quadratic function, and on the bottom, we have a linear function. We're not able to simplify this, and so this is also called a rational function. And by definition then, it's not a power function, and it's not a quadratic function. So the answer is going to be neither. Then, in part D, we're given g of x is equal to x squared plus 2x. This is a quadratic function. But given this plus 2x term here, means that it cannot be a power function.